Hey everybody, what's up? It's Coach Sharf back here with another video. This video is on compositions of functions. So, like I told y'all in class, this is probably going to wind up being two videos. This video is just going to be the notes, exactly what I went over in class. A couple of the examples might have different numbers depending on what class period you were in, but it's the same, same setup for the examples for the most part. And then I'll record another video with some additional examples so we don't get an hour-long video like the inverse function video was. All right, so let's go ahead and jump in. So we've got compositions of functions. Again, if you're just taking down these notes, you can kind of make this the title of them. And again, I'm going to go quickly through these kind of slides because y'all can, of course, pause. So the best way to describe a composition of functions is that we plug in one function into another function to build a third function. So again, we're taking one function and plugging it into the second one. We're not adding two functions. Okay, we're not adding this function plus this function. We're not multiplying them by each other. Okay, so it's not f of x plus g of x. It's not adding. It's not multiplying. Okay, because those would be different. Again, the example y'all see in a minute. F of x is x plus 6. G of x is 2x minus 1. So if I was adding them, it's just, it's adding polynomials essentially. So it's combining like terms. X and 2x is 3x, 6 and negative 1 is 5. So if I added those, it'd be 3x plus 5. If I multiplied them, x plus 6 times 2x minus 1. Again, you would do FOIL or the box method. You would eventually get 2x squared plus 11x minus 6. But again, that's not what we're doing. Okay, we're plugging in the first function into the second function to create a third function. All right, so how we designate a composition of functions is the compositional function notation. So if I have f of x and g of x, again, just as an example, the two different designations are, here and here. It's not the blue and the red, okay? So you have f parentheses, g parentheses, x, close the both sets of parentheses, or parentheses f. Again, I told y'all in class, it's like a dot. It's kind of like the multiplying dot, but it's not, it's open. So f dot g parentheses x. They're both read as f of g of x. So they're both read the same way, f of g of x. You can treat them both the same way. Again, for me personally, I understand this easier. So if you see a problem where you have this, you can always substitute an f of g of x. And again, I'll show that on the examples that we do. You could also, do these in reverse order. You can have g of f of x. Okay. Again, both of these are read as g of f of x. And there's so many more other combinations you can do even with just these. All right. You can stack them. It's not just you use them both once and then you can't use them again. You could do g of f of g of x. Okay. You could do f of f of f of f of x. Okay. You could even add a third one, and you could have h of x. And then you could do h of g of f of x. Okay. So, the possibilities with this are almost endless, even if you just have two functions, but particularly if you have a third, which again, I don't know if this is I didn't look before I started recording the video. The worksheet I have in mind that I know I've done in the past has 3 different functions on them and combines them in different ways. I have to see if I actually have a digital copy though. If not, I'll have to find something else to do. All right, didn't even really need to erase all that, but anyway. All right, so starting with some basic examples, okay? I have this rewritten down there as well, but I'll go ahead and show you f of x is equal to x plus 6. G of x is equal to 2x minus 1. So I have what I'm calling function and numbers, okay? Here, I just have f of g of x like I just showed. Okay, I'm going to get to that in a minute, but I think if I show you all the numbers first, you'll understand that better. So for the number, now I have f of g, but instead of just x, I'm actually going to put in a number. So we're going to start with 5 here, okay? So what you're doing is you're starting with the innermost function and you're building outwards. I just realized I rewrote that incorrectly. I'm sorry. I'll rewrite it real quick. Wow, I noticed it because I want that to be g of f of x. Okay, so oops, trying to connect that. All right, so with this one, f of g of 5, we're going to start with the innermost one, g of 5. Okay, so what color do I want to use? I'll start with blue. All right, so we're going to start with g of 5. Okay, so we want to evaluate our function g of x if we plug in 5 for x. So I'm going to plug in 5 right there, so which is going to give me, I'm going to start by just putting the 5 in for x, okay? I still have the 2 on that side, so I'm multiplying 2 times 5, and then still subtracting the 1 on the end. 2 times 5 is 10. 10 minus 1 is 9. All right, so again, if you kind of, skip over the stuff in the middle, g of 5 is equal to 9. So the way you can kind of treat it is this. If g of 5 is equal to 9, you can essentially replace it in here. So now I've got f of 9. So I plugged in 5, got this answer. Now I take this answer, plug it into the next function. So I've got f of 9. All right, so now I'm going to plug it in here. So again, for where the x is, I'm just going to put my 9 in parentheses plus 6. Again, even though this is in parentheses, nothing for me to do in the parentheses, no coefficient, no exponent. So essentially you're pretending they're not there. Basically got 9 plus 6, which is 15. It's my final answer. So on a test, if I ask you what is f of g, again, you still got to show your work, on the worksheet. But on the test, if I ask you what is f of g of 5, if these are your two functions, your answer is 15. Okay. Down here, and just realize I messed up again when I already wrote it. This is g of f. Again, g of f. So now I'm going to plug in 8. I apologize if y'all can hear the TV in the back. So I'm going to start, again, g of f of 8. The way y'all kind of want to treat it is if you rewrote it like g of f of 8 like this, okay? So I'm going to start with f of 8. Again, just plugging in 8 here. So it's like I've got 8 plus 6. The same basic idea I had up here. 8 plus 6 is 14. So again, you could say, all right, well, I'm going to replace this f of 8 with 14. So I've got g of 14. Even if you stick with this original one, cross out your f because you use that up. You use that function up already. And now instead of plugging in 8, you're plugging in 14. So either way, you've got g of 14, g of 14. So g of 14. Again, I'm plugging in here. So I'm going to have the 14 in place of the x. Still got the 2 in front, minus 1 on the back. 2 times 14 is 28. Minus 1 is 27. So again, if you were to ask on a quiz or test, what is g of f of 8 in this instance? Your answer is 27. All right, going up to the top now. All right, so again, let me minimize my window real quick. Still got x plus 6, 2x minus 1. So now we're not plugging in a number. So our answer, our final answer we're going to get is not going to be a number. That's going to be why I said in the description earlier, I'm plugging one function into the second function to make a third function. So here, f of g of x, again, you're still going to start with what's on the inside. So we're going to say g of x is 2x minus 1, okay? G of x is equal to 2x minus 1. So again, we're going to cross it out like we did earlier. Instead of putting in a number, now I'm putting in 2x minus 1. So I've got f of 2x minus 1. All right. So now I'm plugging in 2x minus 1 up here where I see this x. This x is just by itself. So I'm still going to put it in parentheses. So 2x minus 1 plus 6 on the back end. But again, let's look at it. I got 2x minus 1. Those aren't like terms, so I can't combine them. Nothing out here to distribute. No exponent up here. So 2x minus 1, that's all we can kind of do with the parentheses. Again, almost act like the parentheses aren't there. I've got -1 and +6, which are like terms. So I'm going to combine them, which is going to be 5. So it's going to give me 2x plus 5 is my new equation. So again, I'm going to kind of write it up here just to show you, demonstrate about making a third function. If I asked you what is f of g of x, you would say it is 2x plus 5. All right, down here for this one, g of f of x. So again, same idea. If you want to rewrite it like that, that's cool. So again, even though it's the same two functions, since I'm doing them in a different order, it's going to wind up giving me different answers. Okay. So if I start with f of x, just x plus 6. So again, I can substitute this in for that. So if you do it down here, again, just cross it out, put x plus 6. If you kind of want to stay up here, cross out the f, cross out that x, put the x plus 6. So either way, I've got g of x plus 6. Okay. So I'm plugging x plus 6 now into this g function. So I'm plugging it in for this x. So I've got x plus 6. I'm going to put the 2 in front, the -1 on the back. So now when I'm looking at this, 2 times x plus 6, I got to distribute this. It's multiplying, right? So I know when I did it up here, I was just combining like terms. But again, this is where you got to kind of realize what you're doing mathematically. So 2 times x is 2x, 2 times 6 is 12. I still got the -1 on the back end. Combine like terms, 12 minus 1 is 11. So 2x plus 11 would be my answer for this one. So even though I wrote it in green down here, I'm going to do it in a different color up here. G of f of x is not 2x plus 5. Again, you're not going to get the same thing. 2x plus 11. It's pretty similar here, but y'all see on the next example, we'll get 2 wildly different answers. I forgot to put extras out of parentheses. I just realized that. And I'd wrote it like that instead, g of f of x. But y'all, again, hopefully y'all get it. All right. So tying those together real quick, okay? Tying those together real quick. If it'll go. Active Student, Active Inspire. So slow when you're sharing it with Zoom. All right. So when we originally did the f of g of 5, again, we plugged in g of 5, calculated it, got 9, plugged in 9, calculated it, got 15. So if I were to ask you what is f of, if I just gave you these two functions originally, asked you what is f of g of 5, that's what you would have to do, okay? If I asked you what is f of g of x, I didn't rewrite the math on that. You can go back and look at the last slide, rewind the video, but we got 2x plus 5 when we calculated f of g of x. So now here's the catch. If I ask you to if I were to ask you on a quiz or test situation or even on a worksheet to calculate this first, and then I asked you what is f of g of 5, instead of having to do the two separate equations up here, you could just plug 5 into here. 2 times 5 is 10, plus this 5 is 15. So you see, whether we did the two separate equations or the one combined equation, We got the same answer in the end, 15. Same with the other one. Okay. G of f of 8. We did f of 8. 8 plus 6 is 14. G of 14, 2 times 14 is 28, minus 1 is 27. When we combine the two functions, the new function we came up with 2x plus 11. So now here, if I did g of f of 8, 2 times 8, because I plug in 8 here, 2 times 8 is 16, plus 11. So 16 plus 11, I moved it over here now, is 27. Again, we see that we got the same answer. All right, so one more example. So now I've got h of x and j of x. H of x is x squared minus 3. J of x is 2x plus 4. We're going to start with h of j of a number. I'm going to pick the number. I told y'all to keep it kind of low during class. I will go with 4, okay? H of j of 4. So I got to start by calculating j of 4. Plug it in here. 2 times 4 plus 4. 2 times 4 is 8, plus 4 is 12. All right. So let me switch colors here. Oh, I switched colors. Come on. Hit that blue. All right. So now for here, I substitute in 12. So now I'm doing h of 12. So I'm plugging it into here. All right. I've got 12. Still got the exponent up there. So 12 squared minus 3. It's supposed to be a 2. Doesn't really look like it. 12 squared is 144. Minus 3 is 141. I should have done that in blue. There's a lot of blue right there. So I'm switching colors. It's not letting me. Come on, hit right. There. H of j of 4 would be equal to 141. So as you can see here, I now did j of j. So I'm essentially plugging in the same function into itself. But again, I'm starting with a number here. So let's go a little higher with this one. Let's go, I don't know, let's go 11. Okay. So I've got j of 11. All right. 2x plus 4. So I've got 11. I still got the 2 in front, plus 4 on the back end. 2 times 11 is 22, plus 4 is 26. So j of 11 is 26. So let me rewrite it because I didn't rewrite it. So if I have j of 11, this is now replaced with 26. So I've got j of 26. If you keep it like this, cross out the last j, cross out and replace it with 26. Again, you don't necessarily have to do either of these steps if I didn't make that clear. I just think it makes it easier as you're doing your problem so you kind of realize what you got to do next. So doing j of 26. Again, plugging it in here. So I've got 26. I'm multiplying it by 2 on the front, adding 4 on the back. 2 times 26 is 52, plus 4 is 56. So j of 11 is equal to 56. All right, last one, I'm going to do the functions. I'm not going to prove them, show how they match up, but I'm just going to go ahead and do the functions now. And then that'll be the end of this first video. All right, so h of j of x. All right, again, still got the same two functions. So starting with j of x is 2x plus 4. Again, essentially just substituting it in here. Okay, so h of 2x plus 4. So I got to plug it into here, x squared minus 3. 2x plus 4 quantity squared minus 3. So I got 2x plus 4 quantity squared. Again, when you're squaring something, you're just multiplying it by itself. So if you need to write this step to kind of remind yourself of that, knock yourself out. I still got to multiply these first, so I'm going to multiply them. And again, it's 2 binomials. You can either use the FOIL method or the box method. As you guys know, I prefer the box method. So I've got 2x, 4, 2x, 4. I'm going to go through and multiply my boxes real quick. 2x times 2x is 4x squared. 2x times 4 is 8x. 4 times 2x is again 8x. 4 times 4 is 16. All right, I've got 4x squared, 8x and 8x. Again, that diagonal adds up. 16x. The 16 by itself is the constant. Still got the -3 on the back end. So I do 16 minus 3. So I'm going to get, again, let me change color so y'all can see I'm going to another step. I'll stick it on the side. 4x squared plus 16x plus 13. All right, so h of j of x is equal to 4x squared plus 16x plus 13. All right, now j of x, okay? J of x. So j of x is 2x plus 4. Keep forgetting to rewrite it. Let's rewrite it. Again, just in case you need to, I think it's easier. All right. So we're going to cross out this j of x, replace it with 2x plus 4. Again, if you want to do it here, cross out the last j, cross out that x and do 2x plus 4. Either way, you've got j of 2x plus 4, j of 2x plus 4. So j of 2x plus 4. Plug it in here for this x. So 2x plus 4. I've still got the 2 in front. I'm still adding 4 on the back. I've got to distribute this 2. All right, 2 times 2x is 4x. 2 times this 4 is 8. Still got the 4 on the back I'm adding. So 4x plus 8 plus 4. Of course, I'm going to add 8 and 4 to give myself 4x plus 12. That is my final answer. So j of x would be equal to 4x plus 12. All right, so that's the end of the notes we did in class. Again, I'm going to record another video. I'm going to try to get it in tonight. Might not get it till after school tomorrow, but I'm definitely going to post at least this video and the inverse functions video. Well, the inverse functions video is already on YouTube, actually, or put it on YouTube last night, but I'll post it in Canvas tonight. So I'll get all that posted tonight. If I record the other video, I'll get it in as well with the extra examples for this. If not, I will record that after school tomorrow and get it uploaded. So until next time, guys, see you later.